Hello, today we'll be going over Project 5. So the first question is to simplify the square root of 28. So we're going to go ahead and make a factor tree. So what times what equals 28? Well, 14 times 2. 14 can break down to 7 and 2. So now we've got 28 written as a product of primes. 7 times 2 times 2. Now we're going to go ahead and take those prime numbers and put them under our square root. So 2 times 2 times 7. Now, the square root means that we have to have 2 of a number to take one out. Because remember, it's the opposite of squaring. And with squaring, it's a number twice. So, in this case, we have 2 2's, so we can take one out. The 7 doesn't have a match, so therefore it has to stay under the square root. So this simplified is 2 square roots of 7, and we're done. The next question is a cubed root. That's what that 3 next to the square root means. It's a cubed root of 20x to the third y to the fourth. So once again, we're going to do our factor tree. Break down the 20 to 10 and 2. Break down the 10 to 5 and 2. Break down the x cubed to x times x times x. The y to the fourth can be written as y times y times y times y times y. I don't know if I said that 4 times. Okay, and then we've got the cubed root of 2 times 2 times 5 times x times x times x times y times y times y times y. Now, with the cubed root, it means that we have to have 3 of the same number underneath to take one out. So, notice we have 3 x's, so we can take one x out. We've got 3 y's, so we can take one y out. Now, notice that we don't have 3 of anything else underneath the square root, so that's all we can take out. So now we go ahead and multiply back together, and we get xy to the cubed root of, and then the cubed root of 20y, because 2 times 2 times 5 is 20, and then times y. Now let's go ahead and simplify 4 square roots of 32 plus the square root of 98. So note that we cannot add numbers underneath the square root. So the biggest mistake that I see here is students will write the square root of 32 plus the square root of 98, and we'll get 130. Please note that that is not the correct way of doing this. You cannot add unless you have the same number underneath the square root, then you add the numbers in front of the square root. So, in order to do this, we're going to go ahead and simplify those square roots and see if we can get it to have the same square root underneath. So we're going to break down the 32 to 16 and 2, break down the 16 to 8 and 2, break down the 8 to 4 and 2, break down the 4 to 2 and 2. So now we've got all our prime numbers. Break down our 98 to 49 and 2, break down the 49 to 7 and 7. Got it as a product of primes. So now I'm going to take 4, and then under the square root, I'm going to write all my products, the product of primes that equals 32. So 2 times 2 times 2 times 2 times 2. And then remember, with the square root, it means that we have to have 2 underneath to take one out. 2 underneath to take one out. Now note that we have 1 2 underneath, so we can't take it out. So we go ahead and multiply. So on the outside, we have 2 times 2 times 4, which is 16. And underneath the square root, we're left with 2. Now let's go ahead and simplify the square root of 98. So we have 7, 7, 2. We have 2 7's, so we take one out. We can't do anything with the 2, so it stays underneath. And we have 7 square roots of 2. So now that we've simplified, we have 16 square roots of 2 plus 7 square roots of 2. So if you think about this, you can kind of think of the square root as an x. So now we have it as 16x plus 7x. Whereas up here at the top we had 4, and instead of the square root of 32 we could put an x there, plus a y for the square root of 98. They're not the same. So they have to be the same in order to combine. So 16 square roots of 2 plus 7 square roots of 2 we can now combine because they both have the square root of 2 in it. So 16 plus 7 is 23. So we have 23 square roots of 2. And that's our answer. Okay. Now we're going to go ahead and solve the equation. The square root of 2x minus 1 plus 2 is equal to 11. So we want to get x by itself. So the first thing that we're able to move is that 2 on the outside of the square root, that plus 2. So the opposite of adding 2 is going to be subtracting 2. So we get the square root of 2x minus 1 is equal to 9. Then we've got to get rid of that square root because it's over the x and the 2 and the negative 1, or the minus 1. So we need to, the opposite of square rooting, or the inverse function, is squaring. So we've got to square both sides because remember what we do to one side, we also have to do to the other. So the square and the square root cancel out and we're just left with 2x minus 1, which is equal to 9 squared, which is 81. Now we want to go ahead and get rid of the minus 1. So the opposite of subtracting 1 would be adding 1 to both sides. And we get 2x is equal to 82. Then we want to get x by itself, so we're going to divide both sides by 2. And we get x is equal to 41. Next question. So Sam and David are traveling across country. They make a note of their starting point on the map, as well as their finishing point. If their starting point is A and their ending point is B, what is the total distance to the nearest mile they will travel? Remember, each unit is equal to 100 miles. So there's two different ways we can do this. We can use the Pythagorean theorem, or we can use the distance formula. I personally think the Pythagorean theorem is easier to visualize, so I'll go ahead and do that one first and then show you how you put it in the distance formula. So we need to make a triangle. So let's go ahead and drop down our vertical distance. So I'm just measuring the vertical distance between point A and point B. And that happens to be 11 squares. And remember, each square is 100 miles, so it'll be 1,100 miles. Now I'm going to go across the other way and get our horizontal distance between point A and point B. And that's equal to 10 squares, or 10,000 miles, or sorry, 1,000 miles. And then we can go ahead and draw in our hypotenuse. Please note that the most common mistake that I see in this is that students will try and count the squares in the hypotenuse. Please be careful, that does not work because you're going across the diagonal, which is longer. So now let's go ahead and use our Pythagorean theorem. Leg squared plus leg squared is equal to our hypotenuse squared. Remember, our hypotenuse is always across from our 90-degree angle, or our right angle. So that's going to be our purple line. So we've got our leg squared, 1100 squared plus 1000 squared is equal to x squared. Okay. Then we go ahead and do that out, take the square, so we get 1,210,000 miles plus 1 million is equal to x squared. Add those together. Now we want to get rid of that square on the x, so the opposite of squaring is square rooting. So we've got to take the square root of both sides, and we get x is equal to the square root of 2,210,000. And for this, we're going to go ahead and use a calculator. And we get x is equal to 1,486 and 6/10. But remember, it said to round to the nearest mile. because 6/10 is greater than 5/10, we go ahead and round up. So we get 1,487. Once again, like I said at the beginning, you can use the distance formula. The distance formula is written out there, x squared minus, or x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So we take our coordinate points. Remember, each square is worth 100, so note that I multiplied everything by 100. So we get negative 200, and 800 is where our A coordinate is. B is 800 and negative 300. Then we go ahead and plug in. So I like to use kind of a Punnett square approach if you've heard of Punnett squares in science. So you take your x and your y's and then column row 1 and row 2. So then we want to go ahead and find our x2, which if you follow the column for x and the row for 2, we get 800 minus x1, which is negative 200 squared, plus y2 is going to be negative 300 minus y1, which is going to be 800 squared. So we get 1,000 squared plus negative 1,100 squared, which note is going to be, once we do that out, it's going to be the 2,210,000, and then we go ahead and take the square root, so we're going to end up with the same answer. This also, please note that this part will also help you on the discussion question that asks you about how the Pythagorean theorem and distance formula are similar and different at the same time. So please note, here's how they're similar and here's how they're different. What percentage of students wear sneakers on an average day of school? Round to the nearest hundredth. So, in order to answer this, we want the total number of students wearing sneakers over the total number of students wearing shoes. So, we've got 11 students who wear sneakers. You can see that they're in green. Over our total number of students, so 11 plus 5 plus 4 plus 8 plus 2. And I tried to color code them there. So we get 11 over 30. Then we can use our calculator and take 11 divided by 30 to get our decimal number, which is listed right there. And then we want to change to a percent by multiplying by 100. So when we multiply by 100, we get 36.66666 repeating. And we want to round to the nearest hundredth. So remember, the hundredth place is 2 right of the decimal. So, since 6 is greater than 5, we go ahead and round up to 36 and 67/100%. The next question, what percentage of students wear sneakers or tennis shoes on an average day of school? Round to the nearest hundredth. So for this one, we're going to go ahead and add the number of students wearing sneakers to the number of students wearing tennis shoes over the total number of students wearing shoes. So we've got 11 students wearing sneakers and 5 wearing tennis shoes over our total number of students. So we get 16 over 30. Use our calculator, write it as a decimal. Change the percent by multiplying by 100. Then round to the nearest hundredth, and we get 53 and 33/100%. Remember, on this one we don't round up because 3 is less than 5. So what percentage of students are not wearing boots on an average day of school? Total number of students not wearing boots over total number of students wearing shoes. So here I just took everything but the students wearing boots over the total number of shoes. So we get 26 students over 30. Use our calculator. Change to percent by multiplying by 100. Round to the nearest hundredth, and we go ahead and round up, so we get 86 and 67 hundredths percent. Next, we have a bowl is full of marbles. There are 4 red marbles, 3 yellow, and 5 green. Using this information, answer the questions. What is the probability of selecting a yellow marble? Write your answer as a fraction. So the total number of yellow marbles over the total number of marbles in the bowl. So 3 favorable outcomes, 3 yellow marbles, over the total number of outcomes, so the total number of marbles in the bowl, which is 5 plus 3 plus 4, which is 12. So we get 3 twelfths. We go ahead and reduce, divide the top by 3 and the bottom by 3, and we get 1/4. Now what is the probability of selecting a yellow marble, then selecting a red marble with replacement? So the total number of yellow marbles over the total number of marbles in the bowl. We get 3 over 12, once again, just like we did on the last problem, which reduces to 1/4. Then we want to find the probability of a red marble, so the favorable outcomes would be the total number of red over the total number of marbles in the bowl. So we've got 4 red marbles, and note that because we're replacing the marble we drew the first time, so say we got that yellow one, we're putting the yellow one back in the bowl. So there's still 12 marbles in our bowl. So over 12, which is equal to 1/3 when we simplify. Now to find the probability of selecting a yellow and then selecting a red marble, we times our 2 probabilities together. So 1/4 times 1/3. We'll multiply straight across. 1 times 1 is 1. 4 times 3 is 12. So we get 1/12. Now what is the probability of selecting a yellow marble and then a red marble without replacement? So once again, it's without replacement. So total number of yellow marbles, total number in the bowl, same thing as we've done in the past 3 problems, 1/4. Now we want the total number of red marbles over the total number of marbles in the bowl minus the yellow one that we drew, because we assume we got what we wanted that first time. So we've got 4 red over 5 green, 2 yellow, and 4 red. So we get 4 over 11. And we can't simplify that. Then to find the probability of selecting a yellow and then a red, we need to multiply. So we get 1/4 times 4 11ths. Multiply straight across. 1 times 4 is 4. 4 times 11 is 44. Simplify, divide the top by 4, divided by the bottom by 4, and we get 1/11. Thank you for watching. Please complete Project 5. Feel free to message me if you have any questions.